Hello everyone, and welcome to Earth Archives. I heard that Pluto used to be one of the 9 major planets in the solar system. How did it suddenly become a dwarf planet?
Haha, that story is actually quite fascinating and full of twists. We have to start from February 18, 1930, a significant milestone in the history of astronomy. On that night, an amateur astronomer named Clyde Tombaugh was conducting observations at the Lowell Observatory in Arizona, USA, when he unexpectedly discovered a mysterious celestial body. This newly discovered object immediately caused a worldwide sensation, and people were excited, believing they had found the legendary 9th planet, Pluto. At that time, astronomers had been searching for an unknown planet beyond the outer edges of the solar system. The discovery of Pluto seemed to fill the last missing piece in this cosmic puzzle. Tombaugh's discovery not only sparked lively discussions in the scientific community, but also ignited the public's strong interest in the mysteries of the solar system. Many people imagined the wonderful sights and unknown secrets that might exist on this distant planet. However, as technology advanced and further observations were made, astronomers gradually realized that Pluto's mass and size were far smaller than those of the other 8 planets, and its orbit was unusual, differing from the characteristics of traditional planets. This led to renewed scientific debates and reconsiderations about Pluto's identity. Finally, in 2006, the International Astronomical Union reclassified Pluto as a dwarf planet, rewriting our understanding of the solar system structure.
An amateur astronomer? How did he manage to do that?
Clyde Tombaugh's story is legendary and a great example of grassroots science. Born into poverty and without a college degree, he was fascinated by the vast starry sky from a young age. Despite lacking formal academic background, he never let that stop him from pursuing his dream in astronomy. Tombaugh built his own telescopes, disassembling various mechanical parts from around his home, and worked hard to study and assemble them. His hands-on skills and patience for detail allowed him to carefully observe changes in celestial bodies like Mars and Saturn. His passion and persistence for the stars eventually opened the door to professional astronomy. Tombaugh found a job at Lowell Observatory and joined the highly intense scientific search for the so-called Planet X, a hypothesized unknown planet thought to exist and influence Neptune's orbit. This work required extreme patience and meticulous observation, qualities Tombaugh possessed. With his keen eyesight and relentless effort, he carefully compared thousands of star charts and finally discovered the mysterious object later named Pluto on February 18, 1930. This discovery shocked the entire astronomy community and changed the course of Tombaugh's life. From an unknown amateur astronomy enthusiast to a key figure unveiling a new chapter in our solar system.
Was it difficult to find celestial bodies?
The astronomical observation conditions back then were extremely tough, and Tombaugh's discovery was truly a miracle. Before 1930, there were no computers or modern technology to assist. Everything had to be done manually. Tombaugh needed to take a large number of photographs of the night sky and then carefully compare them one by one, looking for tiny points that moved slightly in the starry sky. These small changes could be the traces of a new planet. This was a task that required immense patience and focus. Each photograph contained thousands of stars, and finding a few moving points in the vast sea of stars was extremely challenging. Tombaugh spent a whole year on this, dedicating long hours each day to photographing, measuring, and comparing. His eyes were almost glued to the star charts with meticulous attention, never allowing himself to slack off. His persistence and dedication ultimately brought astonishing results. On February 18, 1930, he successfully identified the newly discovered celestial body, which was later named Pluto. This discovery shocked the world and earned Tombaugh an important place in the history of astronomy.
Wow, who came up with the name Pluto?
The origin of Pluto's name is full of fun coincidences and comes with a heartwarming story. After the mysterious new object was discovered, scientists faced an important task: choosing a suitable name for it. Surprisingly, the final name came from a young schoolgirl in England, whose suggestion deeply touched the astronomical community. This schoolgirl proposed the name Pluto, derived from the Roman god of the underworld, Pluto. The name not only carries a sense of mystery, but also an intangible power that perfectly matches Pluto's cold, distant, and deep characteristics. Pluto, as the god of the underworld, symbolizes unfathomable darkness and the unknown, fitting perfectly with this small planet's lonely position at the edge of the solar system.
So why was it later downgraded?
In 2006, the International Astronomical Union (IAU) made a historic revision to the definition of a planet, which directly affected Pluto's status. According to the new criteria set at that time, a celestial body must meet 3 strict conditions to be officially recognized as a planet. First, it must orbit the Sun. Second, it must have enough mass for its self-gravity to form a nearly round shape. And third, and most importantly, it must have cleared its neighboring region of other objects, meaning it is the dominant body in its orbit. Pluto met the first 2 criteria perfectly. It orbits the Sun and has enough gravity to be nearly spherical. But the problem lies in the 3rd criterion. Pluto's orbital zone is filled with thousands of other small bodies in a region known as the Kuiper Belt, a vast area of icy small objects. Pluto cannot clear these neighboring objects from its orbit, which means it is not the sole ruler of its orbital path. Based on this new definition, Pluto was reclassified as a dwarf planet, distinguishing it from the 8 true planets. This decision sparked widespread debate and controversy at the time. Many astronomy enthusiasts and the public felt sad about Pluto's demotion, but it also marked a more precise and rigorous scientific understanding of the solar system structure.
That sounds so unfair.
Many people found it hard to accept Pluto's demotion, especially those of us who grew up knowing Pluto as the 9th planet of the solar system. For us, Pluto wasn't just a cold celestial body. It carried the imagination and memories of our childhood. Suddenly hearing it was no longer a planet felt like part of those familiar starry sky stories had been taken away, leaving many with a sense of loss, as if their childhood memories had been stolen. This debate about Pluto's identity exists not only among the public, but also sparked intense discussions within the scientific community. Many astronomers argue that Pluto's unique geological features, climate changes, and even its complex system of 5 moons all support the idea that it should be considered a full-fledged planet. A notable advocate is NASA's renowned planetary scientist Alan Stern, who has long argued that Pluto possesses all the characteristics of a planet and opposes its downgrade to a dwarf planet. Stern points out that Pluto has an atmosphere, seasonal changes, and diverse surface features, traits that planets should have. He believes that using the clearing the orbit criterion alone to deny Pluto's planetary status is too narrow and overlooks the richness and diversity of the celestial body itself.
So, what's so special about it?
In 2015, the New Horizons probe flew past Pluto, unveiling the mysteries of this distant celestial body for humanity. This close encounter completely transformed our understanding of Pluto. It was no longer just the vague, icy dwarf planet described in textbooks, but a dynamic and ever-changing world. Through the high-resolution images sent back by New Horizons, Pluto's surface revealed breathtaking sights. Vast landscapes covered in ice and snow, with massive snow-white plains and rugged mountains, showcased a diverse and majestic terrain. Dark and bright spots were scattered across the surface, resembling a massive natural painting, each detail telling the story of Pluto's complex and rich geological history. Even more exciting, scientists discovered signs that Pluto might be geologically active. This suggests that Pluto is not a cold, dead world, but a planet full of dynamic changes, possibly with internal heat still driving surface phenomena. These vivid characteristics set Pluto apart in the solar system, making it a valuable model for studying icy dwarf planets and celestial bodies in extreme environments.
Does it have a satellite?
Pluto has 5 moons, the largest of which is Charon, remarkable for its scale compared to Pluto itself. Charon's diameter is about half that of Pluto, and its mass is also substantial, resulting in the two bodies forming a unique binary system. Such a binary relationship is extremely rare within the solar system, as Pluto and Charon are tidally locked, perpetually showing the same face to each other, like a pair of cosmic partners. This celestial interaction demonstrates an astonishing balance and harmony of gravitational forces. Pluto has 5 moons, the largest of which is Charon, remarkable for its scale compared to Pluto itself. Charon's diameter is about half that of Pluto, and its mass is also substantial, resulting in the two bodies forming a unique binary system. Such a binary relationship is extremely rare within the solar system, as Pluto and Charon are tidally locked, perpetually showing the same face to each other, like a pair of cosmic partners. This celestial interaction demonstrates an astonishing balance and harmony of gravitational forces.
Does it have any moons?
Pluto's unique orbit sets it apart from all other planets in the solar system. Unlike traditional planets that follow nearly perfect circular orbits, Pluto travels along a highly tilted and elliptical path. This unusual orbit makes Pluto's movement full of variation and drama. Most astonishingly, during certain parts of its orbit, Pluto is actually closer to the Sun than Neptune, a phenomenon that makes its position in the sky unpredictable and all the more fascinating. It takes Pluto a staggering 248 years to complete one full orbit around the Sun, making its journey a multi-generational astronomical event. Each generation sees Pluto in a different location, and our observations and studies of it vary depending on when they take place. The high inclination of Pluto's orbit means that its orbital plane is set at a noticeable angle compared to the orbits of the major planets, something exceptionally rare in the solar system. This distinctive orbit not only affects Pluto's path, but also has profound impacts on its climate and surface features. Because of the orbit's elliptical shape, Pluto's distance from the Sun changes dramatically, which directly influences its surface temperature and atmospheric conditions, giving rise to seasonal geological and climatic phenomena.
Pluto is in the Kuiper Belt. What is that?
The Kuiper Belt is a mysterious and magnificent ring-shaped region that surrounds the Sun, extending from just beyond Neptune's orbit to about 50 astronomical units away. This cold and vast expanse is filled with tens of thousands of small celestial bodies and icy materials, forming the frontier zone of our solar system, full of unknowns and immense scientific value. Among all the objects in the Kuiper Belt, Pluto is undoubtedly the most famous dwarf planet. Like Pluto, many Kuiper Belt objects are covered in ice and snow, composed of low-temperature, primordial materials. These bodies are thought to be fossils, left over from the early formation of the solar system, preserving rich information about the universe's past. By studying them, scientists gain deeper insights into the origins and evolution of the solar system.
Pluto really is special. What about its exploration history?
In 2006, NASA launched the groundbreaking New Horizons probe, beginning an unprecedented interstellar journey. After a long 9-year flight, New Horizons finally reached Pluto in 2015, sending back a wealth of high-resolution images and scientific data that completely reshaped our understanding of this dwarf planet. The images captured by New Horizons revealed the composition of Pluto's icy plains, which are made up of a mixture of nitrogen ice, methane ice, and other frozen materials. These vast icy fields are rich in surface details and offer a stark contrast to the previously held notion of Pluto as a cold, lifeless rock. Even more astonishing, the probe discovered towering mountain ranges rising thousands of meters, possibly made of water ice, indicating signs of geological activity. In addition, the latest scientific data strongly suggest that Pluto may harbor a subsurface ocean. This discovery has completely overturned the traditional belief that dwarf planets are inactive and lifeless. The possible presence of an underground ocean not only implies that Pluto's interior may still retain heat, but also fuels speculation and scientific interest in the potential for life on distant, icy worlds far from the Sun.
What's special about its icy plains?
The most iconic geological feature on Pluto is undoubtedly Sputnik Planitia. This plain is shaped like a giant heart, an unforgettable sight. Composed of nitrogen ice, methane ice, and carbon monoxide ice, the surface of Sputnik Planitia is remarkably smooth, defying our stereotypes of distant, frozen dwarf planets. Based on high-resolution images and data sent back by New Horizons, scientists believe that the ice here isn't static. It's slowly flowing, revealing that Pluto still exhibits geological activity. This glacial flow is similar to the movement of glaciers on Earth and suggests that Pluto's interior may still retain enough heat to drive surface changes. The existence of Sputnik Planitia not only proves that dwarf planets can have active geological processes, but also challenges how we think about the evolution and dynamics of objects at the edge of the solar system.
A planet that far away, and it's still active?
Pluto, once thought to be a cold and lifeless dwarf planet, has revealed astonishing internal secrets as scientific research has progressed. Scientists believe that Pluto's interior may contain radioactive elements that produce heat, an essential energy source for maintaining liquid water beneath the surface or enabling the flow of ice. This discovery has completely transformed our understanding of this remote world. Radioactive elements like uranium, thorium, and potassium naturally decay within Pluto's rocky core, releasing a steady supply of heat. This heat may be sufficient to keep water in a liquid state beneath the frozen surface, even in the extreme cold. As a result, Pluto is no longer seen as a fully frozen, inactive dead world. This internal heat source could drive the slow movement of subsurface oceans or ice layers, phenomena that align with the flowing ice observed by the New Horizons probe on Pluto's surface.
What about its atmosphere?
Pluto, the dwarf planet on the outer edge of the solar system, has an atmosphere that's just as fascinating as its surface. Its atmosphere is primarily composed of nitrogen, with small amounts of methane and carbon monoxide, gases that together form a thin, delicate layer around the planet. Because Pluto is so far from the Sun, its surface temperature plummets to an unimaginable minus 230 degrees Celsius minus 382 degrees Fahrenheit. In such extreme cold, its atmosphere is incredibly thin, almost a vacuum. However, as Pluto moves along its elliptical orbit and approaches the Sun, the surface ices, nitrogen, methane, and carbon monoxide, begin to sublimate, transforming directly from solid to gas. This sublimation process creates a temporary atmosphere, one that thickens or thins depending on Pluto's distance from the Sun. It's as if Pluto breathes in the cold void of space, its atmosphere forming and fading in a dynamic, almost lifelike cycle. Though fragile, this thin layer of gases is enough to create faint atmospheric pressure and winds, potentially influencing the distribution and shape of surface ice.
That sounds so poetic. Sometimes it breathes, sometimes it disappears.
Pluto's mystery and charm come from exactly that, its unique and ever-changing nature. This dwarf planet not only has a transient atmosphere that shifts with its orbit, but also forms a remarkable binary system with its largest moon, Charon. Pluto and Charon are tidally locked, always showing the same face to each other, as if locked in a silent, eternal gaze. It's a rare rotational pattern that gives them the feel of cosmic twins, expressing a harmony that's both beautiful and profound. The uniqueness of this binary system not only makes the gravitational interaction between Pluto and Charon more complex, but also sets them apart within the solar system. Their similar mass ratio causes them to orbit a common center of mass, located outside Pluto itself, unlike most moon planet systems. This interaction gives Pluto a rich set of dynamic characteristics that continue to captivate astronomers and space enthusiasts around the world.
Will humans continue to explore it?
Pluto, the mysterious dwarf planet on the edge of the solar system, continues to ignite boundless curiosity and the desire for exploration among scientists. Despite its vast distance from Earth and its harsh environment, the scientific community has proposed several future missions, including orbiters and even landers, to deeply study this icy world's geological history, environmental changes, and the potential for signs of life. These future missions come with diverse and ambitious goals. First, Pluto's geological history remains full of unanswered questions. Scientists aim to uncover its past geological activity, including possible cryovolcanism, glacial movements, and internal heat sources, through high-resolution terrain mapping and rock composition analysis. Understanding these processes will not only help us decode Pluto's own evolutionary path, but also allow comparisons with other icy bodies in the outer solar system. Second, Pluto's ice and snow cycle is another key area of research. Due to its extreme seasonal variations, Pluto experiences continuous sublimation and condensation of surface ices, resulting in a dynamic atmosphere. Future probes will closely monitor these cycles to help scientists better understand climate shifts and atmospheric physics, knowledge that could offer valuable insights into other cold, distant worlds beyond Neptune.
All right, one last question. Could there really be life on Pluto?
Even though Pluto lies at the edge of the solar system, its surface frozen and temperatures plunging to minus 230 degrees Celsius, scientists remain deeply curious and hopeful about what might lie beneath. While there's no direct evidence yet of a subsurface ocean, various scientific data and theoretical models suggest that Pluto very likely has layers of liquid water beneath its icy shell, possibly rich in organic compounds. The potential presence of liquid water opens up the exciting possibility of life on Pluto. In theory, such an environment could support microbial life. Even if the surface is unimaginably cold, deep underground there might exist a stable, sheltered habitat suitable for life. This idea has sparked great enthusiasm among scientists and space enthusiasts alike, because the search for life is no longer limited to Earth or Mars. Pluto has now become a noteworthy candidate in the quest for extraterrestrial life within our solar system. The presence of organic compounds on Pluto is equally intriguing. Data from New Horizons revealed a variety of complex organic molecules on Pluto's surface and in its atmosphere, basic building blocks of life. While these compounds don't confirm the presence of life, they offer critical clues for future exploration missions and fuel our growing expectations about the diversity of life in the universe.
I see. Pluto may be small, but it carries a big story.
Exactly. It may be just a tiny, dwarf planet, but it holds within it the spirit of exploration, scientific history, poetic mythology, and endless future possibilities. Everyone who looks at Pluto sees a different story and a different dream. Don't forget to subscribe, like, comment, and hit the bell. Let's keep sailing through the sea of knowledge together.